Philip, the floor is yours.
Hello, here's Philip Reisen speaking. So before I dive into my topic, let me lose a few words about the company. So LINBIT is an organization of a little above 30 people. Most of us are working out of Austria, and we have a smaller office on the west coast of the United States. So that is LINBIT, and we have like exclusive distributor for Japan, that's the size group, and working in other areas of the world with partners. So what are we doing? We are providing a software-defined storage. So that is a software that organizes the storage devices in a number of machines and make that a highly available provider for persistent volumes. And that relates to edge deployments, as edge deployment might be only a small number of machines, and you might have the requirement to have reliable storage there. So when does it fit? It fits when you need persistent volumes for containers like Kubernetes, Nomad, Docker. It is a very good fit when you need persistent volumes for virtualization environments like OpenNebula, our hosts here. But we also have drivers from OpenStack. The Apache Cloud Stack driver is in preparation. XCP-ng is also in preparation. Proxmox VE, that is ready as well. Apart from the orchestration technology, for what kinds of application is it a good fit? And it is really a good fit when you have applications that are demanding for I/O. So like online transaction processing, databases, and maybe even message queuing systems, and also for analytics workloads, where you have these workloads that create a lot of read requests, and then the whole data set is exchanged. Our focus is to deliver a storage software that delivers high performance, and do that with low overhead. So again, that makes it a very suitable fit for edge deployments, since there you have limited resources and you want to take as much output as possible from the limited hardware you have available there. So how are we doing that? Most part of our data path, well, all of the data path, that is in kernel. So one aspect is we rely on many building blocks that are available on the kernel and maintain our own replication engine, that is DAVD. So that's one of those pillows we build on. Then the layout of volumes onto different servers, that is done at allocation time. And the advantage of that is that during I/O, so when time is critical, everything is known, and we have a fast data path. Here we are building on existing components, and that is not only to save some work for us, but it also helps your day two operation, because in case anything goes wrong, in case anything needs to examined, debugged, your operation team will work with a lot of existing components, and the software-defined storage is not a black box. maybe even a proprietary black box where you cannot log in. So building on these building blocks has advantages in multiple layers. And as well, a direct implication of all this is that this SDS is very well suited to be used in a hyperconverged way. And again, something what is very well suited for edge deployments because you want to reduce the number of servers you have in these edge locations. So maybe the cluster is as small as 2 nodes. And why that? Because it doesn't consume a lot of resources. So it doesn't consume a lot of CPU cycles, and it doesn't consume a lot of your DRAM. So it's really, really minimalistic on that. And when you know the storage size, you can upfront know how much DRAM it will consume. So there are no surprises in operation of this technology. And in a sense, so this is really the 10 minutes pitch of it. What is it doing? So it is managing your cluster and allocating persistent storage on the storage device. Well, it allocates volumes on the storage devices, gives you persistent volumes out of that. So it manages clusters from 3 to thousands of nodes with some limitations. You can also go down to a 2-node cluster. Supports multiple storage tiers, multi-tenancy or QoS for the storage workloads, and you can have complex allocation policies that considers how the storage allocations should be distributed among your chassis, racks, rooms, etc. How is data made persistent? Well, we always have to live with the possibility of hardware failure or machine failures. So data needs to be replicated in order to be persistent. It does synchronous, asynchronous, 2 or more copies of your data, consistency groups, and here it really goes into the details. It might help you with selecting the right paths over the network if that is necessary in that environment. And business continuity features. So apart from the replication you might use within the site, you might decide to do async replication to an offsite location. But it can also do backup to S3 storage, and then it does that in a incremental manner. So have full backups and incrementals out of that. Yes, so that is basically what I want to tell you in these 10 minutes. So a few more things. So when it comes to the integration to the workload orchestrators we might find in edge deployments. So as mentioned, we have OpenNebula, the integration, but also to Kubernetes. So the full spectrum of technologies that is necessary there, the CSI driver that gives you the principal connectivity to Kubernetes, the operator to roll out the storage software easily, the Stork scheduler extension that gives the Kubernetes scheduler the necessary insight to do good scheduling decisions regarding to the storage, high availability for the storage software itself and for the workload. So for stateful sets in a context of Kubernetes, and nice integration with kubectl plugin. And maybe one word about the business model. So all this is open source software, as mentioned. And we deliver it like in 2 flavors to the consumers. One is the complete open source packaging that is called then Piraeus Datastore. So you find that on the public registries and can use it from there. And we also have a commercial packaging of it that is delivered to customers, comes with support and certifications where certifications apply. But in the end, you get the things built from the same source code. That's like the overview. It covers you from detecting the hardware all the way up, delivering all the storage features, replication, encryption, address, deduplication, caching, and delivers it somehow to the workload. Okay, that was like the 10-minute version of it. And now I'm hoping for some questions.
Thanks, Philip. I think we are all very strict today with the timing. Nice. Well, I had a question for you about the comparison between LINBIT and obviously and Ceph and Portworx and kind of solutions that have been there's been some attempts to use them at the edge environments. They're going to be at some point. But
yeah, thanks for the question. When we compare it to Ceph, and it seems like Ceph became like the dominant storage technology in the open source world. Ceph will consume a lot more resources. So, you know, you have to dedicate multiple cores just to the storage software. And then also its DRAM footprint is not predetermined. You know, you don't know it upfront how much DRAM it will consume. So that all things, that doesn't make it a perfect fit when you want to co-locate it with your workload. And so in that regard, I think our software is really ahead of the game. On the other side, Ceph brings you like object storage and Cephfs as well. We only do a block storage. And you also mentioned Portworx, I think. Portworx is a proprietary player in the field, delivering a software-defined storage for Kubernetes only. And let's put it that way, its architecture is pretty similar. Our stuff is open source and performs extremely well.
So it sounds, I mean, from your perspective, I mean, from a technological perspective, I mean, adapting your technology to edge computing is not going to involve such a massive disruption, right? Of the way you've been designing your solution, right? So it's
yes. So from the requirements that were driving us in the past, I would say what we do is already a good fit for the edge case. You know? And we also have it ready for x86, for ARM64, Power and C, and we are just waiting until RISC-V becomes available that we can make it available on that platform as well.
There's a question there on the chat. I guess it's I take it it's a general question to all of us, but I think, Philip, if you want to give your answer to that.
Okay, I'm reading the question. To what extent OS open source solutions can completely avoid lock-in and full portability, and where instead can exist troubles? Where to start? I would say with nearly everything we do here in the open source world, there is no vendor lock-in because by definition, what we do is open source. If you're not lucky with the one vendor supporting you right now, take another vendor, take it to your consulting company of choice and let them support you. And also, I think all the we don't create proprietary formats, since this is not in our DNA. So this is the best I can answer this question. If anyone else from the panelists want to jump in, go ahead.
Yep, if anyone else wants to, I have my own opinion about this, but I'll leave you give yours. Kai.
I think there was the question also about what else can go wrong, and I would say cloud is the what else that can go wrong. So even if there's no lock-in when it comes to an open source solution, there might be lock-in de facto by being married to one single cloud provider.
But then you married yourself to the API of this cloud provider, right?
Yes.
Mm-hmm. Well, I mean, that's the whole idea behind Gaia X, right? So to be able to create some kind of abstraction layer on top of a number of cloud providers as well.
Indeed.
So, I mean, Philip, we've talked about edge computing, but in terms of large deployments, I mean, how is LINBIT performing in that sense?
Yeah. So the
I mean, we also get the same question sometimes, but how big is your biggest deployment?
Yeah. So we have a CSP here in Europe, a cloud service provider that is currently running LINBIT SDS on 620 nodes, and he's extremely happy about it. And you might know it, they also run Open Nebula.
Okay. Yeah, I mean, one of the challenges of edge computing obviously will be to be able to manage things at scale. So maybe not centralized somewhere, but at least being able to manage all these resources in many different locations in a kind of distributed edge cloud. Okay. Well, thank you. Thanks a lot, Philip, for the introduction and for your time.